Hello again. So yeah, it's me again. I changed hats. I'm not a Mozilla person anymore. I'm a W3C audio working group representative now. As usual, I'm going to do little updates of what's been going on this year. Well, actually a bit more because of the pandemic, etc. What's been going on in the WebAudio API? Talk is called WebAudio API 2.0. What's new? Well, spoiler alert. There is no 2.0, but I will explain that in a few slides. So now a bit of Legalese. The audio working group is a W3C working group. It's been rechartered until June 2024. What does it mean? It does mean that we can continue working, essentially. So we have, I don't actually have the internet, but one sec. I need to open some links. So what does it mean? Yeah, it means so we need to have a charter in a working group to kind of scope the work that we are doing with a number of different companies. So it scopes what we do. It lasts 2 years usually. It's a long document that really explains what is in scope, which is also interesting. For example, what is not in scope is like music notation, but we do work with them. Audio codec selection and support, for example, is not the WebAudio API thing. What are we expected to deliver? So for us, it's specification texts. For the WebAudio API, the Web Media API, of which a new draft is going to come out soon. And then, yeah, tests, use cases, requirements. We can do best practices, for example, performance recommendations, that kind of thing. Yeah, so a bunch of legalese. So that means that we have a few years to work still. And I will talk about the focus of the next few years in a slide or two. So now there is no version 2.0 because the change happened, and we have moved to a process where we update the main texts. It's a lot simpler than having a separate text. So you can already see the new features that we added in the WebAudio API since the recommendation got published. So yeah, it's loading, but we have an interesting way of displaying the new markup. So essentially, it's loading still. It's a really big spec. It's 124 pages if you print it. For example, what do we have? You can have so we have a changelog as always in the spec, and we have a way to display what the current spec is, what the changes are, and only the future text, for example. And so all the different new features are kind of labeled this way. So yeah, it's quite nice. So something I will show later. So new interfaces, etc. You can see all the different, and it's all at the bottom. If you only care about what's new, then yeah, just go to the bottom, and so it saves you lots of time. So I think it's a relief for us because it would be fairly hard to maintain a different specification that refers the main specification constantly, but is a separate document. It would be very hard. So we're glad we can do it this way instead. It's fairly recent W3C process. So now the meat of it, new stuff coming up. We have 3 main work items for 2022, and then I will talk about other things we have for the next year. So the first thing that I talked about yesterday in my talk would be audio render capacity, which is a way. So I'm just going to show the in a normal markup. So so it's a way to know how much of your rendering budget you're using in real time. So essentially, you start the audio render capacity object. It's going to start measuring what's going on. You can also stop it when you want. And periodically, depending on the options you pass, it's going to fire an update event. And the update event will contain a number of things. So first, the timestamp at which the measurement was performed, the average load on this region of time. For example, if you do one event every second, it's going to be the average load for this second. Now you can also get the peak load, which is really interesting for us. You really don't want that to be more than 1.0. And then under-run ratio. So the number of render quantums that were rendered is going to be the denominator, and the numerator is going to be how often did the budget was the budget not met. So also that needs to be 0 for well-performing WebAudio API application. So this will allow you to have average load and peak meters for CPU, and to be able to scale down your processing depending on the device or the load of the device or any other factor. Maybe you want to increase your latency, etc. Well, you can do what you want, really. So it's fairly straightforward. A note is that for fingerprinting reasons, average load, peak load are going to be quantized to percentiles, right? So it's only going to be numbers between 0 and 1, but there is only 100 values, which we felt was enough to understand what was going on. Because too much precision you would be able to fingerprint the user, as we've tried. So there's that. Then there is a bit of examples, and yeah. So this, I think, is almost ready in Chrome, and I've got all the underlying work done in Firefox, but I haven't exposed the API yet, but I will. Next, Philippe will talk about the variable render quantum. So I'm going to just open the tabs, Philippe. So yeah, if you want to.
Yeah. So it's something that that a lot of folks are very interested in, and it's something that's been talked about since Audio, at least until since Audiokinetic joined the community group back in 2019. But it wasn't always discussed this way. Actually, it started off as a separate spec called the Audio Device Client spec. I think that was initially Hong-Chan Choi that came up with it. And yeah, it's very interesting because it was a solution for doing more low-level audio stuff that the Web API was able to do at the time, to fit different use cases like the one that Audiokinetic was interested in, like running large audio applications coming from a different code base and porting it to the web. And yeah, obviously, variable render quantum size was a very valuable part of this audio device client API, because sometimes you just don't need that much low latency for some use cases. It doesn't really matter if your render quantum size is 512 or even 1024 samples. So it always depends on the use case. And sometimes you might want a larger buffer size just to save on CPU because that's more important. But eventually, after a lot of discussion, it was decided that just writing a separate spec to perform some of the same things that web audio was already doing would be kind of a waste, maybe. And there was too much overlap. So eventually, this very important concern was kind of extracted from that and brought into web audio itself. So now it's being discussed as an improvement on web audio itself. But of course, that brings a lot of concerns, like what do we do with the FFT functions that are being used in a lot of the different type nodes that web audio supports, if we can no longer rely on always having 128 sample buffer sizes. So yeah, that's why it's taking maybe a long time to nail down this spec, but it's very important, and it's probably something that's going to happen in the near future, I hope.
Yeah. Thanks, Philippe. And as far as implementation work is concerned, we are holding off on that until next year. I think we're going to start working on it 2023, because we're already doing other things right now, and it's fairly, I mean, it looks like 2 attributes really, but it's fairly involved in the engine. So yeah, we are laying the groundwork and not rushing, but it's going to be really, really good for performance. And then last one, SetSyncID. So if you know the HTML media element counterpart, it simply allows to output the sound to a different audio output device. So enumeration of audio output devices is already taken care of by WebRTC APIs. So navigator.mediadevices.enumerate devices. You need to have access accepted to share, let's say, your microphone or something like this, to have access to the name and characteristics of the device to prevent fingerprinting again. And the audio context grows a new set of attributes to be able to change the output device. You have 2 ways to do this. Either you can construct a new audio context directly with the ID of an audio device. So if you do it this way, then the sample rate of the audio context will be the preferred sample rate of the audio output device. You can also dynamically set the sync of an audio context, and if the preferred sample rate of the audio output device is different, then resampler will be inserted and possible latency will be increased because of the resampling process. So yeah, you have a bit of both style here, and we have also event handler to notify users and authors that the sync has changed. So for example, if you if you're running on the default audio device and you unplug, let's say, USB sound card, it will fire the event to you, and you will be able to react, maybe recreate your audio graph, or ask the user to select a new one, or I don't know, like any use case really. So this is not particularly hard. The problem we have is mostly about privacy and enumeration. For example, if you haven't enumerated the devices, can you create an audio context on the non-default audio output? We tend to say no, because that will expose a number of characteristics of the audio output device, such as, for example, the number of output channels, or the sample rate, or the latency. The problem is that in the world we live in, it may look like nothing, but it allows fingerprinting and making every user on the web unique. And then you've got people that will use that to track folks across the web. So we are trying to prevent this. So this API is going to only work if the user has consented to share the characteristics of their audio setup, whether it is input or output. So yeah, this is not very hard to implement, in the sense that we already do all the switching and complex things today, because you can plug and unplug and change the default audio output device, and it continues running. It's just exposing in the web browser internals. And there is also one thing, which is the non-sync. It's very useful when you don't want to output audio, because, for example, you're already outputting audio for something, but you want to analyze the audio only, but you're not going to be outputting it. this might end up going towards a design where you don't need user permission to start it because it's not going to make sound. Yeah, so it can be fairly useful if you're playing music and you only want to do analysis with, let's say, analyzer node or worklet. So yeah, it was easy to just pass the non-sync, which is a special string that will just have no audio output device. It also means that the audio context will run on probably on a lower priority thread and not on an audio callback. So that saves power as well. What do we have next? So that's the things that are coming up this year. That's the features that we're working on. What do we have for after? So I'm just gonna, there's gonna be a series of tabs that I'm gonna open on the tracker. So the things that we have worked on, spec is almost finished, but it's not merged yet. It's new native nodes. So noise generator and noise gate expander. I think we have a design. I don't know where it is. Yeah, here. So Raymond specs this. So it's very simple noise generator node. It has a few characteristics. You can seed it to have reproducible results across runs. For audio is not that important, but it's really, really important for testing. And also if you are rendering pieces, so it's the same each time. Because remember that you can also use it for modulation, right? So white noise or that kind of thing kind of sounds the same each time, but if you're using it for modulating something else, then you maybe want to have exactly the same sequence each time. You have a number of different noise types. So yeah, different weighting. And then if you want, let's say pink or whatever, you already have all the filters in the WebAudio API to very simply get your get the type of noise that you want for your application. So yeah, that's going to be coming. I think the spec's finished, but we are focusing on other things now. Noise gate expander. So this is a fairly old issue, reported 16th of November 2012. So essentially what we're going to do, instead of doing an expander or a gate, we're going to offer a envelope follower. And then it's going to be fairly straightforward to connect it with a delay, gain node, wave shaper, or even audio worklet if you really want precise processing. You will be able to do noise gate and expander. You will be able to do sidechaining. Yeah, because remember that the WebAudio API compressor, I'm gonna load it. It's just I thought I had a diagram. I think. Yeah, so that's more or less what is the dynamics compressor in the WebAudio API. It's just a set of nodes connected to each other. So by offering an envelope follower with a bunch of parameters, we'll be able to implement a variety of compressor. Again, I just want to remember you the fact that the dynamics compressor in the WebAudio API is very opinionated. It doesn't work at all for all use cases. It's really a bus compressor and not really for individual channels. So yeah. So that's something we're going to implement soon. But we really go towards a composability approach and not a big complex node that does one thing well but doesn't suit everybody, etc. So we are trying to do smaller nodes that compose well instead of big nodes, which is a little bit of a departure from the original design, but we feel that it goes further. It goes further. Now, that's what's coming up right after, so probably sometime next year. And then we have categorized all the issues. So that's what we think is the most important things to work on. So I mean, it's just a grab bag of bunch of things. So we already have things we already talked about. User selectable render quantum, like Philippe said. Audio output device. That's also fairly important. But other things that we care about, for example, phase offset of oscillators, power law automation for panning, so panning left and right with power law to keep the energy constant. Band limited pulse oscillator to be able to do variable PWM. That also has the design laid out. You can, by the way, see all that online and comment on any of those. But I mean, the PWM is like fairly uncontroversial, really. It's got a pulse width, and that's about it. Other things that we care about are, so I labeled also new features in the. That's lots of unknown on those. That's stuff that people have requested, but we haven't had lots of discussion on that. Some things we really know that we will do, for example, exposing the audio context in a worker instead of the main thread. Not so much the service worker, but regular workers, we will do that. Some things I know very little about, for example, deconvolver node has been requested, but there's been no traction by anybody else than the person that requested it. Multi-channel panner node, so to be able to do multi-channel 3D panning. Little things here and there. Channel layout detection is something that Philippe requested to be able to know if it's an 8-channel output of a sound card that is geared towards musical application, where each channel is independent, or is it a 7.1 home cinema setup, right? So for now, in the WebAudio API, you cannot make the distinction, but we will add an API so that you will know, is the third channel center, or is the third channel just the third channel? Because it's just like a regular music type sound card. And something that I care about very much is to be able to access the performance objects from the audio worklet global scope. So you will be able to make your own measurements from within the worklet to do performance measurements. More importantly, when this lands, you will be able to insert your own profiler markers from your own code. So let's say you're writing an audio engine. You'll be able to insert your own markers, for example, for your own DSP blocks, and be able to know how long it took without having to change the web browser. So that's going to be quite good. And then, tweaks on the filters, as always. Bunch of little things. So there is less certainty on all of this, but that's what we consider for the future. Of course, as always, you can, if you want to have your voice heard, just show up on this issue tracker and either use the emoji reaction things or write something a bit more substantial explaining why it's important for your use case. Always happy to have comments. Audio worklet features that we are considering, as I was mentioning yesterday. Two things. I mean, the last two really are kind of the same. We might close one because it's not useful to have two. But being able to only use WebAssembly without JavaScript and with skipping copies with WASM is something that we care about a lot. It's going to be a lot better for ergonomics and toolchain ecosystem. So that's what the last two are about, even though the title don't really reflect what it means. And the other thing was open not too long ago, is a way to just use post message without having to instantiate the worklets, right? To set things up, that kind of thing. Fairly simple, but we feel it's a nice ergonomic improvement, and we couldn't find a reason why we shouldn't be doing it. So we ended up kind of deciding that we would be doing it. So that's it. But as always, I mean, I'm gonna reload this, but so 86 issues open. You can always add more. It's you just click the new issue thing. There is a little template that you have to follow so that it's easier for us to understand what's going on. And yeah, see, I mean, we have a lot more issue closed than open, so that's good. But yeah, please, as always, I think I'll be repeating myself every year, but please come and talk to us to steer the WebAudio API in a direction that works for you. As you have noticed over the last few WACs or few years, we have spent a lot of time making sure the audio worklet would work for everybody. But now it seems to work for lots of people. So we have final few tweaks, and then we might go back to native nodes because people like them, and there is obvious blind spots that we would like to address. If you can just show up and plus or like thumb up the issues that you care about. Again, github.com/webaudio/web-audio-API is very simple. It hasn't changed in ages. Yeah, so please just show up.
And also, if I may, another way you can get your voice heard is to join the community audio working group.
Yes,
right?
yes.
So that's, as far as I know, anyone can join. And the meetings are bi-weekly. And you can just pop up there and get your voice heard and actually discuss the issues live with Hong Chan and Paul and everyone from the working group. So this is what Audio Kinetic has been doing for the past 3 years. There's on and off, not always, but it's a great way to get your voice heard. And right now, there's not that many people in the meeting, so there's plenty of room for a discussion.
Yeah, it's on and off. Some people join, some people very frequently, and some other because the agenda is posted in advance. And when you want to talk about something, I mean, we are always super happy to have you, of course, but sometimes you really don't care about what's going on this particular day. So like, it's okay to not show up. Yeah, there was a developer survey that was fairly interesting. So the developer survey was open to any person. You didn't have to register to W3C or anything. We used it. We collected a bunch of answers. There was also a free form at the bottom. So we took some time to read it. Hong Chan did some sorting of the answers, and it informed the priorities that I've talked about. So there was lots of people answered. Yeah. So here is the detail for the meeting. If you come to the Slack channel, we share the URL. It's just a Google Meet thing. It's very like laid back, no stress really. So to join the community group is it's very simple. Just make an account and click here.
It gets you on the mailing list, and I think Hong Chan posts a message on the mailing list every time there's a meeting.
With the agenda, the links, etc. So yeah, and you don't have. So this is free to enter, right? Completely open, no registration. If your entity isn't a W3C member, you don't care. You can join either with an affiliation. So let's say you represent some company or project, or you can also join as an independent person. It's up to you. You don't really have to reveal your affiliation to the group. What do I have left? Yeah, aborted project. So we won't be doing the audio device client because it was fairly easy for us to port the little features that the audio device client had, the audio worklet didn't have, and it's better to have a non-fragmented ecosystem. So yeah, we won't. We still keep the text for archival reasons, but yeah. It was. I'm just going to click.
This was the alternate spec I was talking about when the first variable render quantum size was being discussed.
Yeah.
Was originally discussed as a separate spec, and it also had the select output device selection as well.
Yeah.
So those two features were extracted and went into Web API instead.
We felt that the difference were minimal, and then we could make it easier for anybody. And just fold the little differences into the main text, so people could also compose with the native nodes and also the worklet. And we focused on making sure that the worklet was as efficient as it could be and would work well with everything. So. Yep. Yeah, that's it. I don't have anything else to say. So I'm just gonna, as always, like if you want to contact me, I can relay to the group. And yeah, just click the GitHub thing. You've got all the repos. It's like just a regular GitHub organization. So you've got all the repos here. This one is not used anymore. You remember we had a V2 thing, but we moved back all the issues to the main one, so it's consolidated. Yes, Norbert?
First of all, just a little remark. I think you're doing an amazing job altogether, and every time I look, it works in the right direction. And now you mentioned that you felt that keeping the nodes very simple and kind of low level would be something else than others intended at the beginning or something. I never thought that. They're all pretty simple and low level. I think an envelope folder is a
there are obvious counterexamples. For example, the HRTF panner, like there's something fairly complex in itself. The dynamics compressor is like too opinionated, doesn't work for everybody. So we could have used something a bit more flexible with more options, but it's set in stone now. But yeah, generally we favor composability, and that's been the case for some time. But we didn't feel like, for example, adding a noise, like just noise gate. If we can have one primitive, and then with 3 lines of code, people can build the type of noise gate that they feel like. We felt it was a better approach. But yeah, I mean, we don't really want nodes that are too complex or magical or implement something too specific. We prefer small building blocks. The dynamics compressor was just a pain to specify. Yeah, really. We don't want to do that again. Yeah.
Hello. I have a question related to render audio quantum, which I'm very excited about. So thanks for that. And I mean, vaguely related to that, but mostly related to audio worklet. I don't want it to come across as a feature request. I know where those go. But I want to ask, because I want to get an idea of how present this is among yourselves in the development group, and also within users, if it's of interest. So my interest is in analysis, and you spoke about the audio render quantum as something that would affect performance mostly. So I was wondering if there's any talks about overlapping frames, which is something very common, especially for analysis, but also for synthesis in some cases. And I know that that is the equivalent of just having a small audio render quantum, and that would be your hop size, and then you accumulate frames basically, which is what I've been doing in audio worklets. But that gets cumbersome, and that becomes most of the code in the audio worklet to have a buffer that you accumulate frames on and to do your overlapping. Has there ever been any talks of like hiding that maybe and just providing a frame size and a hop size parameters for the worklet?
Yeah, so we kind of thought about doing it, but it felt like it was better suited by a JavaScript code because it gets pretty specific, and so we felt like the user they know best. Well, programmers know best what they need to do, and we also felt like we wouldn't be able to provide any more performance. It would be slightly better ergonomically, but it would bloat the API a bit. Yeah, we couldn't provide more performance or something that the JavaScript wouldn't be able to do. So it was left out, and we instead ensured that it was possible to implement it very efficiently by users of the API. Yeah, it's an exercise that we do very often. Try to determine what is best. Is it best in the API? Or is it best to provide the tools so that it can be implemented perfectly? And the second option is reasonably often what we favor, because then you have a long list of things that become possible that we hadn't thought of, because people have very good ideas very often. So, but yeah, that's the type of API designs that we favor these days.
Unless there are performance reasons to do it in the browser.
Exactly, Philippe. Unless there is performance reasons, or like very, very specific ergonomic reasons, or we can move the needle from including it to excluding it.
Okay, thanks.
Yep.